guys, Michael here, and today I thought I'd actually go ahead and do another part for the Stop Repeating Yourself series. Well, I guess it's going to be a series now, where I thought I'd actually kind of go into a bit more detail and kind of show you how you can take what I showed in the first part and kind of build upon that and essentially make it more, well, reusable, which in this case is kind of the whole point of the series, is showing you ways to create logic that you can then reuse in multiple different scenarios that's essentially configurable. Just as a quick overview, in terms of the last episode, what we did is we created this actor component called an action performer. It was initially called something else, but we since renamed it during that episode. It's a component you can add to any actor that's in your scene, and then you can change some settings, and that kind of affects how it behaves. So what I'm going to do is I'm going to start by just opening up the action performer and go to the main event graph. So as a quick reminder, on the begin play, this is kind of where we set up some of the binding for the begin overlap event. And we have some logic here that automatically sets up that on to make sure that the actor itself can generate the overlap events as well. Now, with a particular component like this, it might be that you might not want it to trigger when the overlap begins. You might want to do it on the end overlap, for example. There's quite a few ways we can kind of accomplish that. We could, if we really wanted to, make a completely new action performer type of thing. Or alternatively, which is what we're going to do in this particular episode, is actually configure it so you can choose and select which one you want. And that can be quite handy because then when you're in the level, you just select it. Oh, yeah, I've changed my mind. I want that on end overlap. And then you can just press a button and change it. You don't have to worry then about swapping the components or anything like that, which can take some time, particularly if you've got to delete the old one, put the new one in, and then set all the other settings up. It's not always convenient. So let's go ahead and jump into it. So we do have this logic at the end just to make it so that the owner can generate those overlap events. So what I'm going to do, just to help keep things a little bit tidy, I'm just going to pop that in a function. Call that force generate overlap events. Just like so. Yeah. Right, so that's gives a little bit more space and just tidies that up a little bit. Now, what we can do using the get owner again, we can do the type in bind, and we get all the various bind events that are available already on an actor. So just as a reminder, when we use the get owner, making sure that the target is the actor component, that will always return the actor that it's on. So the reference type is going to be of type actor. So that means that we can access all the various events and things that are built into the actor itself. Now, there's some events here specific for damage. So you can do some for take any damage, take point damage, or take radial damage. So this can be quite a good way to create kind of components that handle when the player receives damage. So you could do it where it'll essentially takes the data that it receives from it and then chooses what happens. And that can be quite a nice way of being able to create something more configurable that you can then use across all your NPCs and the player characters, even just general actors, that when they then take damage, because anything that's in the scene essentially is an actor. So that's just something to be aware of. And again, we've got all the various overlap type events and even the on actor hit. So what we can do, if we do the bind event to on actor end overlap, again we can pull from the event pin and do the create event. So this kind of allows us to choose what happens when the overlap ends essentially. Now in this example we probably want to keep it the same, just so it's the same logic. So thankfully, because it has the same inputs as the begin overlap, we can just use the same function. So that's the on owner overlapped, which is this one here. So what I'm going to do is I'm actually just going to rename this function just so it's a little bit more apparent, just because it's not specific to when it's overlapped anymore. Let's have a look. We could put on triggered. There we go. So we can assume that yeah. So when it's either begin overlapped or when it's ended, it will call that on triggered event. Okay, now we kind of just want a nice way to be able to actually decide which one of these is going to bind to. So we've kind of got a few options. We can just do a ball. So on end overlap, like so. And then we'll just move these around a little bit. Like so. So yeah, and then let's add a quick sequence at the beginning. Just because we want this to fire regardless of the output of this specific event. So we'll move that to the front. So just a reminder, the sequence, it executes in the order. So it'll start with this branch here. So it'll execute everything on this side, well, up to it ends, and then it'll then come to the next pin, and then execute everything on that bit. So with that, we just want to make sure that this particular variable is instance editable, and that'll then allow us to toggle that on there. So we have this one here, which is destroy, and let's just double check which one it is. So select that one there. Okay, so when we overlap with this one, well, in this case, end the overlap, it'll destroy this particular one. So we can quickly test that. So if we overlap with it, nothing happens, but then we end the overlap, that's when it then fires. So, and that's something that we can then quite easily configure. So again, if I just untick that, this time it will just do what it did previously, where as soon as you overlap it, it destroys. Now, of course, if you've only got two options, this can be quite a nice way to do it, but depending on what you're sort of doing, you may end up getting quite a few options that you might want. I know in the past myself, I've created things that kind of hook into not just the overlap events, but also specifically to an interaction system that I have as well. So I was able to have it perform something when the owner is interacted with, in addition to the normal interaction stuff, as well as the overlap, and kind of being able to configure it that way. Okay, so just before I continue, I thought I would quickly jump into Project Sunrise and just show you one of the examples that I have created in this particular project. It is available on the Fab Marketplace as well, so feel free to check that out if you're looking for an interaction system, a quest system, dialogue system, that type of stuff. But yeah, as a quick example, as part of the sort of example content that I created, I wanted to set it up where when the player first interacts with this door, it essentially assigned them a quest. So as a part of the system itself, there is a quest assigner, and this is just something that I can drop onto an actor, and I can specify the trigger type. In this case, I have the overlap and end overlap, as well as the interact and interact end events. The interact ones, they just hook up into the interaction system that's available within this project, and then as part of that, I can then decide, well, I can then specify the quests that get added. And this is just a reusable component that I can add to anything, and I can quite easily just change how that all works quite easily. So in terms of the sort of trigger types, that'll be something similar that I'll be showing you how to set up in a second. So what we can do in that particular instance is where enumeration can be quite handy. So for this, let's do action performer triggers. So we'll start by starting the first two. So on overlap, too many, and on overlap end. So, and then coming back to the action performer, instead of using the ball, we can choose the action performer types, and we can change those, and that's going to break a few things, but don't worry. So we'll just remove that branch, And instead what we're going to do is actually replace that with a switch. Now a switch is great because it can have multiple pins, and with an enumeration it will essentially have the same number of pins as there are entries within the enumeration. So you can kind of decide what happens. So in this case, I want to swap those around. So this can be quite a nice way, just because if you decide you want to add another one, it tends to be a little bit easier just to update and add it into the list. Let's just rename this as well to the action trigger, and we'll move that up near the top. Like so. So now when we do it, we have essentially a drop down, and we can choose what sort of action that we want. So whether it's on overlap or on overlap end. So as you can see, there's quite a lot of ways you can kind of build upon this and add the various different action types or events you want. In terms of this particular episode, all we're focusing on is just what's specific to the actor type. But if you have specific types of actors, there's nothing to say that you couldn't make components that are able to function specifically on those types of actors. That are, kind of allows you to then just cast if you wanted to a specific type. You just have to remember that when you are doing something like that, it does kind of limits the scope a little bit in terms of what it's on. Well, can be used on. But again, that's not always an issue. It's kind of figuring out what's best for your specific project. The next thing I kind of want to go over is instance structs. In the previous episode, we did add an option here where we could specify a structure and essentially able to pass that information onto the action that we specified. So as a reminder, we have this scale one here where we can pass in the instance structs, and it'll attempt to use that particular scale. Now, this can be quite nice, the fact that we can pass that information on, particularly if we have quite a few other ones. So what I'm actually going to do is quickly create another child of the linker action, and I'm going to call this one teleport. And again, I'm just going to override that run action. As a reminder, that's just a function that we set up in the parent, and there's nothing in there. It's just so we can override it in the child. Again, we don't need the parent call, so we can just remove that. Now, what we could possibly do here is have it where it actually teleports the player or the thing that overlaps it to a specific location. So we can set location, well, set actor location, and we use the linked actor because that's what's passed through. And then we can attempt to get the instance struct value again, and we can connect that in like so. Now this sounds all well and good. It's very similar to the scale one in terms of how that's set up. Now let's just convert that to one of these. Now, whilst it may be obvious to you and I who've set this up that we want a vector, if we come out of here and change this to, say, teleport, we have no way of knowing, particularly if this is cleared, what sort of structure that it's expecting. Now, as you can imagine, that's not going to be particularly helpful. Of course, we could just go in and open it up and take a look, but again, as it comes to a workflow, it's not going to be very enjoyable in the long term. So the question is there anything we can do to help mitigate that? And the answer is yes. Yes, we can. So in terms of the linker action, we do always go ahead and pass through an instance struct. I'm going to go ahead and just rename that to payload, just so it makes a little bit more sense. Just so you know, this is inside the linker action, and it's just on that run action function. What I'm going to do as well is actually create a new variable in the linker action. So again, this is the base, and that's going to be an instance struct. I'm going to call this one default payload. Again, I'm just going to leave this as none, so we can kind of ignore that at this particular point, but it's kind of just in there. And then what we can do, let's say if we go to the scale, we will need to just reconnect the payload there, and update that. And similarly with the teleport. Like so. What we can then do, on the class defaults, we can actually specify the default value for this. Like so. So if we remember correctly, this should be a vector, because that's what we're after. Why is it not? There we go. For scale, let's just default it to 1, 1, 1. Like so. Similarly with the teleport, whilst it's probably not easy to specify a specific value, we can at least put in the type, so that's going to be type vector. Now, some of you might be thinking, well, kind of what's the point of this? Because at the moment, we're not actually using it anywhere. And you're right. However, what we can actually do is come to the action performer, and we have the instance struct here. And again, in the previous episodes, we never named this, so I'm just going to call this payload again. Just double check that's not broken anything. Nope. And in the action performer, we can then create a new function. I'm going to say get default payload. And in the details panel, with the get default payload selected, we're going to tick where it says call in editor. Now, call in editor is quite a nice option, where with the component selected, we now have a little button we can actually click on in the editor, which means if we click this particular button, it's going to call that specific function in the editor. So this is kind of a nice way to allow you to be able to kind of call a little bit of logic directly in the editor without having to wait until runtime. So you can kind of set some things up, or even in some cases calculate things before we get to that runtime. So you kind of do some things in the editor ready for runtime. But in this particular example, what we're actually going to do is we're going to get the action. So this is the action class. So this is where we specify the type of action we want. We want to pull from that. I want to get class defaults. And you'll notice that when we do that, it'll create this little node here, and it should just say default payload because that's the only variable that we have in the linker action. If we added more variables to the linker action class, which is what this variable type is, they'll show up in this list as well. In this example, we don't need to worry about this specific one. What we can actually do is get the payload variable, and we can just set it to whatever that default amount is, which can be quite nice. In addition to that, we do just want to make sure that the class type is valid first. So I'm just going to convert that to a validated get. This will just mean that if we haven't got a class selected and we press that button, it just means nothing will happen. So if we select this one here, so this one's got the teleport on there, but we're not sure what it's expecting. So if we click the get default payload, it's going to run that function, and then it's gone ahead and set the structure that we require to the desired one. If we was, so I've just cleared that out. If we change this then to the scale one, and we do the same thing again, it's gone ahead and set that again. Again, it's another vector. I think the values are different. But it kind of gives you a bit of an idea of how you can then start to kind of make things a little bit easier when it comes to kind of building some of the functionality that you're wanting and making it more reusable. So already we've kind of got it set up where we can kind of do something like that. Now, with the way that we've kind of got things set up at the moment, we do have this linker action here. Linked actor, get my words out. And at the moment we're always passing that through to the action here. Now there may actually be times where we don't need a linked actor. So the question we should be asking is, does it need to be there? And the answer is probably not. Now this kind of gives us a little bit more well, it kind of poses a little bit more of a question as to what it is that we can do. So instead of having a linked actor here, it should probably be a part of the payload section where we essentially pass the actor through as we need to. Now at the moment the payload is just a single structure, so if we wanted to we could go through and create different structures for the different types of things we want to do, but that itself can get quite messy, particularly when you start to get quite a few different actions that you might want to perform. So instead what we can actually do, instead of having a single payload that we pass through, we could kind of move more to an array. So as an example, what we can do, if we get this payload here, and we're just going to convert that to an array, that is going to break a few things, don't worry about it. We are going to slowly fix those. So the first one, obviously we've got the default payload, and that's attempting to set it, but the default isn't an array either, so that's why we get this error. So if we go ahead and jump into the linker action as well, in the default payload, we want to go ahead and set that to an array also. If we compile in here, that's fixed, but this one isn't now. So now the run action function, we kind of want to change the input payload on that as well to an array. So that should then fix this one. I'm just going to make sure that's reconnected. Okay, so now at this particular point we are kind of passing everything through. So we do still have the linked actor here, so I'm just actually going to remove that. And I'm going to remove that from the run action input as well. And let's just double check to see if that's being used anywhere else. So it is being used on the intriggered. Just to get there, validated get, so we can remove that as well. Now at this point we can just remove that variable. So with the payload, now we have an array, we can kind of do something to include it in here. Now I'm not sure if there's one specific for actor. Okay, yeah. So at this particular example, we don't actually have an option for an actor. Not a problem. In these specific examples, it would just be a case of creating a structure. So for this one, we could do a linked actor, and we can just add a variable to that of type actor, do that as an object reference. And then in the list here, we should be able to see the linked actor. So that's the structure we just created, and we can then specify the actor again. And that's kind of done within the payload, as it were. So now it's just a case of actually going through and updating the actions that use the linked actor that's no longer available, so we can use it essentially. Now, when setting up these, we kind of have to go through things a little bit differently. So in this scale one, I've just unhooked everything to start with, and we want to do a for each loop to begin with. And this is going to essentially allow us to loop through all of the elements within the payload that have been passed through, so we can then kind of start doing some checks with them. So in this particular example, we just want to get an instance value. Now we do need to make sure that we're getting the linked actor specifically. So let's do a break linked actor, and we'll just plug that value into there, and then we can just put that to a local variable in this particular one, like so. Now if we've gone through and it's not the specific one, we can then go ahead and do another check. So in this case, we want to do it as a scale, sorry, a vector. So we'll put that as desired scale, and that's going to be of the type vector. And just like so. So what we've kind of done at this particular point is when we call that run action, we're going through and we're essentially extracting the data from the array that's passed through and organising it. This means that when we then come to actually doing what we want, for the desired scale, I just want to make that the default. That's 111. So we no longer need this little bit here, so we can kind of shimmy those out, and then we connect the linked and desired scales. Like so. So this one here, let's change that to the scale. We do need to update the default action as well. So we want a linked actor, and then we want a vector. So, and if we just get the default values, we can reconnect these. And the scale we'll set to 2 by 2. Now this particular one, this blue one, that should all be working. Yeah, the others have errors, but we'll get to those in a second. So now that's still working. So now through the actor component itself, a lot of the data at this particular point is being passed through. So we specify the action and we specify the payload, as well as the trigger. So we're kind of keeping all the data within that payload section, and we're handling that through the action itself. So we're starting to sort of really increase sort of the modularity of this, kind of to the point where there might be certain things where we don't actually want, we can kind of have different options into things. So we have so let's move on to the not the teleport one, we'll do the teleport one last. Let's go to the destroy one. So in this particular example, all we did was just destroy the specific actor. So for this one, we just need to do another for each loop. And we want to get the instance struct value again. And we want to break linked actor, just like so. Now, the great thing about what we've just done here is this is going to loop through, and every single linked actor it finds, it's going to call that destroy actor. Now, some of you might have kind of already figured out what I mean by that, but let's show you. So previously, if we wanted to destroy multiple actors, we would have to go ahead and add multiple of these components, which again isn't ideal. It's a lot of work, a lot of effort. Whereas now, if we set this to the destroy and get the default payload, there is nothing to say that we couldn't have multiple linked actors within the array. So let's destroy that one, and that one. So now in terms of this particular white cube, when this one's overlapped, or let's change it to when the overlaps end, it's going to go ahead and destroy all of these specific actors. So we're in the cube and then we leave. Bam! Just like that. So now we're really kind of getting into the kind of like the power of instant structs, really. Now, obviously, they can be a little bit difficult to wrap your head around to begin with, but hopefully with some of these examples, it's going to make things a little bit easier for you to hopefully start incorporating them into making these more reusable assets and components, essentially. Okay, so the last thing we've got to fix is the new teleport action that we've created. Now, again, we're going to start with a for each loop. Now, we kind of have a little bit of an issue here in the sense that actually, when we want to teleport somebody to something, we kind of need the target, but we also need the location. Now, the location itself could be a vector, but sometimes we might want it to be an actor as well, in which we get the location from. So we kind of need to think of a nice way to be able to facilitate that. So I'm just going to pick one of these. I'm going to change that to the teleport one. So we kind of need to think about how it is that we're going to distinguish between those, because if we had like a linked actor here, there's kind of no way to distinguish what it should be. Whilst we have this structure here that's just an actor, we could go one step further and let's add a gameplay tag. Let's make it a gameplay tag container, maybe, yeah. We'll just call that tags. And I'm going to move that up here. So now on all of these, so we have this one here, we have these empty tag containers, that's fine, but we still have the actor listed. Now all of these should still be perfectly fine. Some things shouldn't have broken. But you will notice that on the break linked actor, we do have this tags option as well. But that's okay. So what we can kind of do now is we get the instance struct again, and we do the break. Actor. We can then kind of do like a contains. Is that the right one? Has tag. Has any tags. I was kind of hoping to have the other one. Has all tags. Has any tags. Which one is it? Tag. There we go. So make literal gameplay tag container. And that will allow us to specify some gameplay tags that we can check for to determine if it's what we want. So in this particular example, we want... Actually, is that the best way? Possibly not. Let's do it where... So I'm just thinking in terms of a scalability and conflicts issue. Actually, instead of it being a gameplay tag container, I'm just going to do a normal gameplay tag. It does limit things a little bit to just one tag, but I think for this specific video it's probably a better option. So what we can actually do with the tag itself, we can just do a switch on gameplay tag. Let's remove the default pin, and then we can specify the tags. So in this case we do want to create some new tags, so we're just going to go to the manage gameplay tags section, and we're going to add a new tag, and I'm just going to do this for performer. So we'll add that. Oh, I need to specify the source. So I'm just going to pop it into the default gameplay tags for now. And then I'm just going to add another one. Destination. So now we have two tags. So we have destination and then we have target. So we come in here and so destination and then targets. So what we can do then from the actor, we can create local variable, so we'll call that target. And then we'll just want to duplicate that as well, we'll call that destination. and we can then just connect these up like so. So as it loops through the array, it's going to, if it gets to a linked actor structure, it'll check the tag. If it matches the destination tag, it'll set the destination variable to the actor inside, and similarly with the target. Now we do want an additional variable. Actually, the destination, I'm just going to rename that to destination underscore actor. And then for the new one, that's going to be the vector. This one's going to be the destination as well. Now you're probably thinking, well, we've got two destinations now. What are we going to do? So the first thing we do need to do is set the destination. So again, we can get the instance struct. So if that one's not valid, it'll then check the next one. Like so. On the completed, we do need to then set the actor. However, as I'm thinking about it, what we probably want to do is make sure that the target is valid first. So this is the target that we're going to be teleporting. And then the new location, we kind of want to check a few things. Yes, it's valid, and then we want the destination actor. Again, I'm going to do a validated get on this. And if it is valid, we're going to get the actor location, and we're just going to override the destination that's in that variable. And that's just going to allow us to open a sequence here. So I'll quickly explain this again, because it might seem a little bit strange what we're doing. So in essence, what we're doing is we're kind of reusing the destination variable. So we do set it up here if the instance struct is a vector. However, we kind of need to decide what we're favoring. So generally, if you've gone through the trouble of specifying a destination for the actor to teleport to, we can assume that's probably what we want to use. So in this example, we're going to prioritize the actor. So if there's an actor and a vector that is specified, the vector will essentially be ignored. So it'll go through and it'll kind of set all these things up. But then on the completed, we check to make sure we actually have a target. If we don't, then we do nothing. If we do have a target, it's then going to check, do we have a destination actor? If we do, we'll get the actor location from it and set it to the destination vector. So this will override whatever gets set up here, if it's set at all. If not, then that's fine. It'll just use whatever this destination is. So if we don't specify a destination or a destination actor, this will just be 0, 0, and that's where things will get teleported to. But again, not a major issue. Now, in terms of this particular teleport, it should be done, I think. So let's test it. We do just need to set up the default values, actually. So let's just quickly do that. So we want to do a linked actor. With the linked actors, you may actually notice that in the defaults we don't get the option to specify the actor here. And that's just because we can't specify actors from a level in here because it's a hard reference, so it has to be loaded. And we can't do that from within these. It'd have to be a soft object. But we can still specify the tag. Now this can be quite useful because it means we can specify the valid tags that we want. So we want to make sure that we've got a target and we want to make sure that we've got a destination. Potentially. So put those in there. And then lastly, we'll just do the vector as well. Right, so, and then if we come back here and we do the get default payload, we can kind of see what these are. Okay, so the linked actor is the target, and then we've got the destination. So if we wanted to, we can just remove some of these. So let's say, well, let's keep it for now. Let's say the destination is going to be that cube over there, so we'll probably end up intersecting it or end up on top. So we can kind of just ignore this vector one, so we'll just remove that. Now, one of the problems we do have in this particular example is that the linked actor is not set. We can't. So we could, if we wanted to, like set this cube, for example, so that it's going to, when we overlap this, it's going to move this cube over to here. So we'll quickly test that. Just like so. And that's, I'm going to be honest, looks pretty cool. Quite like that. Whoop. But what if we want to do it as the player? Now, we can't specify the player here at all. There's no option for it. So we kind of need to think a little bit more out of the box, really. So when we actually run the action, we don't send any additional data in terms of what's overlapping. So we kind of need to think a little bit about how it is that we're going to get that information to it. Because the issue that we have, once we get into the run action, we have no context to the world, so we only get the data that was passed in. Now we could always pass the data through, which to be fair is probably not a bad option. Which may be actually what I want to do. Yeah, I think that's what I'm going to do. So on the run action, I'm going to come in and add a new input, and this is in the linker action. That's going to be of type actor. And I'm just going to call this instigator. So the instigator is going to be in this example, the thing that's triggered the action to be performed. In a lot of cases, this could just be the player. So that kind of gives us access to the player from within the run action function. So we'll look at utilising that in a second. Now we do just need a way to be able to pass that through. So on the triggered, we have at the moment we have the overlapped actor and then the other actor. Now I'm pretty sure it's the other actor that we need, but I guess we'll find out in a moment. So in this example, because we are only dealing with overlaps, we're always going to have that other actor. If you're using other types of events that you're binding to, you might need to get a little bit more creative in terms of how you get that instigator reference. Okay, so we've got that data passed through now. So we go back to the teleport. What we could always do is add an additional one where we it's the one for a ball. I'm not sure if there is, but let's have a look. There's a named ball. Tagged. Again, we could use another gameplay tag. Let's add another one to the action performer. We'll do instigator as target. So again, what we can do down here so I do apologise, my mouse is a little bit strange as of recently. I think the button clicks are slowly dying on me. Okay, so what we probably want to do is, can we just connect that into there? Yes, that looks like it wants to allow it. Now in this particular example, we've only got one tag that we're currently using. And if it is instigator as target, we want to set that to the instigator that is passed through. And we just want to make sure we're getting the one from the LA teleport. So that's the input on the run action. Like so. Now, if we come back to here, instead of having this linked actor here for the target, if we remove that and we add a new one, we want the gameplay tag. And we can just specify that as instigator as target. We could always move these up. So now it should teleport the player. Oh, there we go. So now when we overlap this one, we get teleported to the cube. So that's yeah, that's a bit more of an in-depth view on how we can add different types of trigger options. Again, you can go absolutely ham-bone on that, and how we can utilize more of the instance structs to add more customizability to our individual actions. So yeah, so hopefully you found this particular video helpful. So yeah, just enjoy. If obviously if you do use this system or whatnot, by all means jump on the Discord. I do have a section on there for sort of showcasing the stuff that you make. And obviously if you make anything, you should always be proud of what you make, because some of this stuff is not easy. So do jump on there, share what you're working on. It's always great to see it. I do also just want to say that Project Sunrise is available on the Fab Marketplace. So if you're looking for an interaction system, dialogue system, and a quest system with some other things, do go ahead and check that out. It can be a great starting place if you're planning to start a new project. Also, I'm on Blue Sky. I will leave the link in the description if you want to follow me on there. So yeah, just want to say again, thanks for watching and enjoy the rest of your day. Take care. Bye.